Hi guys, so in this section we'll be doing mirror formula. So we'll be looking at various aspects and then solving a bunch of problems, easy ones first. So what is the mirror formula? The mirror formula is 1 by f is equal to 1 by v plus 1 by u. Now we need to understand what is f, what is v, what is u, and what is the sign convention we use while putting the values of f, v and u such that this formula alone works for all the various conditions what we have done earlier. So if the formula needs to work for the virtual image formation as well as for the real image formation as well as uh, for the convex mirror, like this one is the convex mirror, for the concave mirror, if the formula has to work for all of these, the same formula has to work for all of these, we have to go through a sign convention. So let us look at the formula more closely. Yes, so we'll see each variable very closely. The first one being f. So what is f? Your f is focal length. Now what is focal length? That's the distance between the pole, so I'll mark the pole, and your focus. So the point of focus on the principal axis is f, which we are taking midway between the pole and the center of curvature. So that's your C. So f will be the radius of curvature by 2. It will be half of it, and we have done in which cases we are going to take that when the aperture is really small compared to the r itself, the radius of curvature itself, when the aperture is small. So I'm not getting into that discussion. So what is f over here? F is the distance between p and f. That's your small f. So I'll just mark it. That length is your small f. Now coming to V, what is V? So let me just make a rough diagram for the object and the image form. So object, we are taking all the time the foot of the object on the principal axis. So that is how I am making it over here. And my image formed will be somewhere over here because this is beyond C. This will be between F and C. This distance would be greater than that distance. So roughly I've just made a diagram. Now what is your V? What is V? V is your image distance. Okay, so I'll label it image distance. That is what your V is. V is your image distance, and what is that? How far is the image from the pole? Again, all distances you'll be measuring from the pole. So yes, I'll just mark it over here. So this length is going to be your V. How far from the pole is the image form? That's your this guy. This one is your image. That's your image. So this distance is V. And then what is U? You would have guessed it already. Your U is the object distance. What is object distance? Again, taking it from the pole, the distance from the pole to the foot of the object on the principal axis. We are taking all the images and objects which are which are having very low height compared to the values of f and r itself. So again, that has been emphasized earlier. So I'm just saying that this u is the distance from P to the foot of the object. The object itself would be of tiny heights. Okay, so now we know that what are F's and V's and U's are. What is F, P and U? But then straight away plugging in the values of f, v and u is not going to help us, because there is a certain sign convention what you have to follow. If you don't follow the sign convention, then the formula may result in wrong answers, because the same formula, you are going to use it for various cases. So in fact, let me just derive the formula very quickly for you, so that you understand why the formula is not consistent for all cases unless until the sign convention is used. So before the sign convention, let me just derive the formula for you. So I thought I'll skip the derivation, so I'll do it very quickly so that you have a bit of perspective over here. Mind you, the derivation is not required for your syllabus. It is, but it is such a easy derivation, and we have been doing a lot of triangles in mathematics, so it will be fun deriving it. So I'll rather do it. Do note what your f is, what your v is, what your u is. Please make a note of it. Make this diagram, because I'm going to clear the board now. Okay, let me make a object over here. We know that the subsequent image is going to be formed somewhere over here, and there are multiple rays. Any two ray, when it gets reflected, they are going to meet over there. So for our derivation sake, what we are going to do right now is derivation. Yeah, so the image is going to be somewhere over there, and there are millions of rays which are responsible for it, and I'm not going to draw the million of rays. I'm going to draw the one which is going to help me in the derivation. So a ray which strikes the pole gets reflected following the laws of reflection. So your angle of incidence must be equal to angle of reflection, and the ray goes back somewhat like this. So the image formed, let me just take it to be here, must be touching that ray, right? So I guess everybody agrees to that. I'm not going to make the other rays which is going to converge over here. All the rays which are going to hit the mirror are going to converge over here. From this tip which is going to hit the mirror is going to converge over here. That's the reason why the image is getting formed over there. I'm not going to make all of them. Now, what does the law of reflection tell us? It says that this angle must be equal to that angle. Hence, this little triangle over here is similar to that triangle. I'm not even labeling it. If you want, you can label it. So, let me call this height of the object as HO and height of the image as HI. Now, what we have already done earlier is the distance of the object from the pole. So this length, how much is it called? It's the length over here on the principal, along the principal axis, as told to you. So I'll just mark it over there. So what is it called? What is it called? It is called U. So I'm going to mark a U over there, and this thing would be V, right? So I'm going to mark V over here. This is your V, and that's your U. Now, following the ratios of similar triangle, what can we say? We can say that my HI by HO, the bigger triangle height by the smaller triangle height, these are the corresponding sides. So that's my HI by HO. What will it be? So these two triangles are similar. So the bigger height divided by the bigger base would be the smaller height divided by the smaller base. So the bigger base is V. So I write my V over there, divided by the smaller base is U. So I have one relation, and mind you, what we are doing it, what we are deriving is, we are out there to find this relation. 1 by F is equal to 1 by V plus 1 by U. So we have a V in one of the formula, in the formula what we derived right now. We have a U, we don't have a F. We have to involve the F somewhere. In these triangles, the F is not figuring, F is over here. So we would require another diagram where we can somehow involve the F in it. Okay, I can make a line from here to there involving C in it, and then after all, the center of curvature, the radius of curvature would be double the F. I can go with that, but I'll rather make another diagram and involve the F over there. Yeah, so what's the intention? The intention is to somehow involve F so that we can have that F which is figuring in the formula. So let me make a parallel ray, go and strike the mirror. What is going to happen to that ray? We all know it. It is going to strike the mirror and bounce back and pass through the focus. Yes, it passes through the focus. So I have successfully involved F, and I have to have a triangle where my focal length is coming into picture. So focal length is from here to here. First, let me just complete my image. Okay. So your focal length is from here to here, here to here. So which triangle can you involve? So what I'll do is, I'll make a triangle over here. So the base of this perpendicular is almost at the pole, almost at the pole. I hope again you can see the fact that if the curvature was quite flat, then where the pole is, when where these points are, they are almost together. So we are deriving this formula assuming that the curvature is quite low. I mean, that can be easily assumed if with a decent curvature also your height of the object is very low. So I have discussed that earlier, and again I am repeating that point because it is coming up again and again. So in this triangle, what is this height? That is the object height, right? So that is, this guy is your HO, right? I'm trying to involve this triangle, and then obviously this triangle. Why? Because those triangles are definitely similar, because this is vertically opposite angle. This angle is say theta dash. This angle will also be theta dash. This is a 90-degree drop, so it is a 90-degree over here. This is also a 90-degree. Two angles same, so the third angle has to be same. So it's again similar triangle, and I guess we have successfully involved this length, which is the focal length F over here. So what is the ratio I can write? I will again go for my HI by HO. So this time, what is my HI by HO? Shall I write here or just complete over here? Okay, I'll write over here. HI by HO. So the bigger triangle, this is the bigger triangle height divided by the bigger triangle base. How much is this? This whole length from the pole till that point, that was your V. This much was your V. How much will this alone be? How much will this alone be? How much is that? That would be a V minus F, right? Because from here to here is your F. So this length is your V minus F. Okay, you can pause the video and you can continue doing yourself, finish it off, and then you can resume. So and so HI divided by the bigger base, which is V minus F, divided by HO divided by the smaller base. I mean, HO is corresponding to the smaller base. Smaller base is this triangle base, which is F itself. So the bigger height divided by the smaller height is the bigger base, V minus F, divided by the smaller base, which is F itself. So this is the relation we get. Now, from the first equation and from this equation, what can we say? We can easily conclude that your V by U, which was HI by HO, is equal to V minus F divided by F, which is again HI by HO. Now, what we have got is a relation where only U and V and F is there. So the final relation we wanted only V, U and F. So whatever this gives must be the answer. This must be the answer. So we'll just tidy this thing up and write it in a better way. So what do we get? We get V by U is equal to V by F minus F by F, which is 1. And then we can bring the V down or divide all of this with V. What do we get? We get 1 by U is equal to 1 by F minus 1 by V. So we can take the 1 by V on the other side, and that results in the world famous mirror formula. So that is how you get the mirror formula. Now you would say that where is the sign convention coming in the picture? Now the sign convention is not coming in the picture. How we wrote everything and we directly got the answer with the correct sign. Why? Because deliberately I chose this diagram. Had I chosen the other diagram, your minus and plus would be all messed up, and you'll get another formula which would look like. Let me just write it over here, right in the where it is of no significance, and I'll write it in red, okay, so that you know that this is not a good formula. Had I taken another diagram where the image is getting formed behind the mirror and used just math without any sign convention, just the math like we have used over here, we would have got something like 1 by f is equal to, okay, I'll write a plus 1 by f, we'll start with the plus 1 by f is equal to 1 by v, but a minus over there, plus 1 by u, when your object would have been in between O and F. You can try it out or don't try it out, it is useless. So you are seeing that we'll have the same ingredients, 1 by F, 1 by V and 1 by U, but the plus and minus will not be same in different conditions, particularly when the image of the object is on the other side of the mirror, and we want to be consistent with the formula. So we'll do that. So as a homework, what you can do is just clear the board. Please note it down before I clear the board, and I'll just give you the homework. Please note it down. So what was this? This was your derivation of the mirror formula. Okay, this thing is called the mirror formula. So let me make the object between the pole and the focus. So in this case, you can derive the formula again. What's the thing happening differently over here? Your image will be formed behind the mirror, it will be virtual and erect. So either you can do it as a homework or pause the video and do it. So hardly it will take, I mean, those two steps only. You'll have to make a diagram where the ray is striking the pole. I think I'm going to do a bit of it for you. Actually the derivation and all is not required, but then when you do this, it is going to make it amply clear to you what's the use of the sign convention. Okay, so if you have doubts that whether you should use sign convention or not, because the formula is straight away simple geometry, whether you should use it or not, why the whole world is using it, this derivation is going to tell you that yes, you land up with a different kind of combinations and you would not like to derive all the time, and you'll rather use a formula. So using a formula is a matter of convenience anyways. So this is the ray. So the first diagram was when the ray strikes the pole, it goes away. So you can use this triangle and this triangle as similar triangles. You'll have your V and your U. This is your U, that's your V, that's your HO, that's your HI, and you can have your HO by HI or HI by HO is equal to V by U. And then what is the other image, the other ray what you're going to use? The one involving the focus somehow, right? So this goes, strikes the mirror and then goes back as if coming from the focus. So my height over here is too much. Don't mind it when I'm going to make it retrace it. It is not going to go there. This strikes back, goes like this, and it goes to the height. So assume it is going there. Okay. So now which triangles would you use? I'll change the color so that the triangle is, you somehow have to involve your F, right? So which triangles would you use? So one would be this green triangle, right? That was used last time also. And the other one would be this big green triangle. Big green triangle. So in the big green triangle, the only difference what is going to come from last time is this base length is going to be V plus F. Last time it was a V minus F, and you'll see that you'll get a different format of the formula when we are using the V and U's and H's just as numbers, and we are not using our sign convention. When we are not using a sign convention and these are just numbers for us, they don't have any sign to it, nothing like a plus 10 or a minus 10 to it, these are just numbers, then you end up with a slightly different formula than your 1 by F is equal to 1 by V plus 1 by U. This is not going to come in this, and you have a slightly different format. Get the point? So we don't mug up the format in different format for different image formation, and we rather use a sign convention and do a single formula, and that single formula is 1 by F is equal to 1 by V plus 1 by U. That's the single formula we are going to do with the sign convention. So we'll look at the sign convention now closely so that the formula works in all cases. Yeah, so let's see what the sign convention is. So first let me just put how they state it. Okay, so what they say is distance measured in the direction of the incident ray, in the direction of the incident ray, are positive distances, and the ones measured opposite to the direction of the incident ray are negative distances. Okay, now this, if you follow this, you might get confused. I mean, this is absolutely right, and this is the right sign convention what everybody is using. After all, it's a convention, mind you, it's a convention. Okay, if you use your own convention, you'll still get your answer. Your convention has to be consistent, you'll still get your answer, but you might not get marks in board. Why? Because you write your own signs and everything, and the teacher will not know your convention. So unfortunately, this convention, the word convention means everybody is using a certain sign scheme, and you'll have to use the same sign scheme so that your working out of the problem is understood by everyone. So it says that distances measured in the direction of the incident ray are positive. Now let me ask you this, that suppose this is your concave mirror. Okay, that's your object over here, that's your object over here. Now the incident ray is this way, incident ray is obviously this way, so the directions measured this way are positive and the opposite way is negative. This way direction is positive, and if I am measuring something the other way, it is negative. That's what the statement is. I'm just making the statement clear to you. We'll have a very easy way of doing our own sign convention which is consistent with this one. So but I'm just making the statement clear to you. Okay, so the direction of the incident ray is positive. Now if I have to say what is U, what would you say? What is U? U is the object distance, right? This guy was the object. This is U. Is U positive or negative? Is U positive or negative? Okay, don't think of the answer in terms of what you have already learned. Okay, most of you would be knowing that U is taken as negative all the time. But according to this statement, is it positive or negative? How would you know? So how you would know is by doing another line of the convention, which is this. That's a very important line. Okay, if I don't have this line, I'll tell you what happens. If I don't have that line, then what happens is, if I measure like this, I'm measuring my u like this, I'll say u is positive. If I measured, my hand went from here to there, and I measured, this is the length u, and it is positive. Get the point? And if I measure it from here to there, you see the direction of measuring, I'm starting from here and I'm going that side, and I measured, the length is measured, again u, but it is opposite to the incident ray direction. Incident ray direction was this way, but I went opposite to the incident ray direction and measured it, then u is negative, right? Quite complicated, right? How you measure it. Get the point? You have distance between 2 points. How you go from here to there or there to there is what the sign convention is telling you. So, what is the allowed way? What is the convention way of going is, you have to start from the pole. You always start measuring from the pole. So, what happens? Your measurement allowed is with the starting point over here all the time, whatever you are measuring. That's the starting point of measurements. Any measurement you are doing, among f, u and v, mind you. Okay, don't measure the height from there. Okay, okay. So if I start from here, I'll make a fresh diagram. This is a bit messed up. Let me just clean it up. Yeah, so let me make a concave mirror. So that's my concave mirror. And suppose the object is over here. Object is over here. That's your object. Now, the allowed way of measuring is from the pole of the mirror to the point, from the pole, so your pole is over here, that's your pole, so you measure from here to there. So if I measure from there to there, what I get is, I get this direction of measuring. That's the direction of measuring. Okay, so it's much like your vectors. That's the direction of measuring. So it is clearly opposite to the direction of the incident ray, because the object is over here. The object is going to give out many rays, and the rays which is incident on the mirror is going to travel in this direction, right? So the direction of incident ray is this way, but you're measuring the opposite way, hence your u is negative. So that's what the convention says. Okay, your image gets formed over there. What would be the image distance? Again, you'll measure from the pole. And here what I'm getting is, I'm getting my u as negative. If I'm measuring my image distance, again I have to start from the pole and go to where the image is formed. So again I measured in this direction, which is opposite to the incident ray. Okay, always compare to the incident ray. Don't say that image is formed by the reflected ray, so you measure along the reflected ray. That's not the convention. The direction is along the incident ray, positive. Okay, opposite to the incident ray, it's negative, whatever you are measuring, v, u, f, whatever. Okay, so you get your v as negative again in this case. And what about f? Where is your f? That's your f, right? That's the focal point, and the length from here to there is your f. So you are measuring it from where to where? Again from pole to the point. Again from pole to the point. So don't mug up f. That is also following a convention. And you're measuring from pole to the point. Everything you're measuring from the pole. From the pole, from the pole, from the pole. So again you are measuring it opposite to the direction of the incident ray. Hence your f in this case is also negative. Okay, so that's the convention. So can you quickly tell me, had it been a convex mirror, I'll just draw a convex mirror over here. That's your convex mirror, and we all know that in a convex mirror, no matter what is the placement of the object, the image is formed here between your f and and P. So can you tell me about the conventions of U, V and F over here? Pause your video and just tell me what will it be, what will it be according to the rule, and then we'll do the simplified rule obviously. So yes, pause now. I hope you have got it. Your incident ray is again onto the mirror like this. So this direction is your positive direction. Now let us measure the U, V and F. So I'll pick up another color to measure it. So I am measuring my U first from the pole to that. So I measured it opposite to the incident ray, right? So my U measuring is negative for sure. If I have to measure the V, what's the V? Let me put it in blue. V is from the pole to where the image is formed. So this guy, this blue ray is in the direction of the incident ray. It is in the same direction. Okay, it doesn't matter it is left side or right side of the mirror. It is in the same direction. Therefore, it is a bit complicated to go by this statement. Anyways, it is in the same direction. So it is positive. So the V measurement is in the direction of the incident ray. What about F measurement? F, where is your F? I'll put it in another color now. This is your F. And how to measure it? Again from pole to F. So you measure from the pole to F. So this is the way you are measuring from the pole to F you are going. So you are in the direction of the incident ray again. So this is again positive. So don't mug up that convex mirrors as positive F. This is the reason. Now obviously doing the convention like this is bit of a pain. So I'll tell you a easier version for the same thing, and let me just clear off the board. Yeah, so I've drawn both the mirrors. There's a concave mirror, there's a convex mirror, and the convention is going to be same for everything. That was the point of convention. So the simplified way of putting the convention is that the object side is always negative. Object side is negative, whichever side the object is, it is negative, and obviously object will be in front of the mirror. Now let me just be little politically theoretically correct over here. This is a, it's like real object side, okay. And in TENS we just have real objects, we don't have virtual objects. We can have virtual images, we don't have virtual objects in class 10, so you don't worry about it. So let me be absolutely clear on this. Let me just write it as, since the object is always going to be in front of the mirror, right? You don't keep an object behind the mirror. That's your, suppose this is a plane mirror, would you keep an object over here? Will the object be over here? What's the use of the object over there? There would be no image formed because it won't be the incident rays won't be striking the shiny side, right? So object is always in front of the mirror, right? So in fact real objects are always in front of the mirror. Let me put it this way, since the object is always going to be in front of the mirror, whatever is in front, whatever measurement you are doing in front of the mirror, I mean whatever among your F, V and U, okay, whatever measurement you are doing in front of the mirror, for this things is your object, image or the focal point, okay. Things is that the object, the image or the F, okay. Whatever measurements done for things in front is negative. It is negative. Front is negative. Front of the mirror is negative. So whether you have object this side, image this side, this is the front of a concave mirror, right? So this side, whatever measured, would be negative. whatever you're measuring this side is negative. So this is the negative side. Okay, front of the mirror is negative side, and whatever is on the other side. So what can be on the other side? In concave mirror, only the image can be on the other side. So if it is on the other side, then this side is positive. It is consistent with the normal convention, because whatever is in front of the mirror, if I start measuring from the pole to that point, it will be opposite to the incident ray, so that will be negative, and what is behind the mirror will be in line of the incident ray, so it will be positive. So forget about that thing. Okay, whatever is in front is negative, other side is positive. Okay, behind the mirror is positive. So what do you think, which side is positive, which side is negative, which is the front of the mirror and which is behind the mirror? Your front of the mirror is obviously, this is the shiny side, so this is the front of the mirror, so that's your front. That's your back of the mirror, right? So whatever is in front is negative, so this is your negative side and this is your positive side. These distances are negative, these distances are positive. I hope you got it. Whether it is above the principal axis measuring horizontally or below the principal axis, doesn't matter. Okay, this side is negative, that side is positive. We are talking about horizontal distances currently and not the vertical ends. Okay, so I hope you got it. I'll just quiz you with one or two variations and let me see what you say about it. Okay, before even I place an object, just tell me what would be the focal length of a concave mirror. This is a concave mirror and this is the shiny side. I hope you can make it out. This is the front. Here, this is the front. So focal length of a concave mirror, just tell me what will it be. And similarly, focal length of convex mirror. So what is focal length of concave mirror? Will go by the convention. Is the focus in front? Is the focus in front of the mirror? Is this point, that's the focus, right? That is the focus, halfway between your C and P. So that's your focus. Is it in front of the mirror? Yes, it is in front of the mirror. Okay. So will it be negative or positive? Whatever is in front is negative. So this focal length has got to be negative. Wherever the image is, wherever the object is, doesn't matter. So focal length of a concave mirror is always negative. Has to be negative because the focal length, the focus is on the shiny side, is on the front side of the mirror. Similarly, in a convex mirror, what is going to happen? Your focus, which is midway between C and P, has to be behind the mirror because C is behind the mirror. It is behind, it is on the non-shiny side of the mirror. So your focus is on the back of the mirror and back of the mirror is always positive. So irrespective where the image and object is, the focus of a convex mirror is always positive. Okay, convex is positive, concave is negative. Now we can place the images, the object in various places and get the corresponding images, like, and the placement of the object will be where? Either here or there or there or there or there or there or there. All these object placement is in front, right? So what can we conclude? What can we conclude? That in a concave mirror, object is always in front, so it is negative. In a convex mirror also, object you are not going to place behind the mirror, it will always be in front, wherever it is going to be in front, and front is negative. So what we can say is object distance is always negative. So U is always negative, 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 no matter what. The value of u is always negative. Okay, this positive and negative you are going to use when you put a value to f or v or u. You're going to use the sign convention. When you put a numerical value, don't write u as minus u because u is always negative. No, if u is 10, it must be a minus 10. Don't call u as minus u. U is u. Get the point? Meaning to say 1 by f is equal to 1 by v plus 1 by u. Somebody says, oh, u is always negative or what? And then changes the formula from a plus 1 by u to a minus u over here. And then somebody reads, I'm just kidding over here, okay? Don't take these formulas seriously, okay? Then he said, oh, u is always negative. So he puts a negative, and then this becomes a plus. So it keeps on flipping in his head. That is not the thing, okay? When you see the variables, you don't put any sign to it due to the convention. Don't put any sign to it due to the convention. When do you put the sign? When do you put the sign? You put the sign when you are substituting any of those values. 1 by 1 second. Like 1 by f is equal to 1 by v plus 1 by u. I have to substitute. I say focal length of a concave mirror was 20 centimeters. They will not say from minus 20 centimeters. Minus and plus is your convention. They say concave length of a focal length of a concave mirror was 20 centimeters. So when you substitute that 20 instead of f, what are you going to write? You will say, oh, it's a concave mirror. Then the focal length always has to be negative because the focus is in front of the concave mirror. So you'll put in a value of minus 20. When you put in the value, then it is that minus. I hope you are clear with the convention of V, U and F. So what we get is U is always negative. F for a concave mirror, I'll just clear the upper part, it looks like a mess. Yeah, so what do we get? What do we get for a concave mirror? We are getting our f is always negative, u is always negative for sure, right? Right? For a convex mirror, f is always positive, u is always negative, whether it is a convex mirror or concave mirror, because the object has to be in front of the mirror all the time. So these are like fixed. Don't mug it up, okay? Just do the convention. These are fixed. You should know the reason behind it. The V will be the only one where you have to think about it. Okay, most of the time V is getting calculated, and it will come with a sign positive or negative depending on whether the image was in front of the mirror or behind the mirror. So in convex mirror, V will always be what? What do you say? What do you say? V will always be positive. Why? Because in a convex mirror, the image is always behind. Okay, so this is pretty much fixed, right? All of them are fixed for a real object which is in front. Okay, again I'm saying real object because when you go to higher classes you'll see the locha over there also. Anyways, and in a concave mirror most of the time it is positive because most of the time the v comes, the image comes this side itself, either here or there or there or there. Okay, so it is most of the time negative, most of the time negative, but for a particular case, the image comes on that side, and in that case, V will be what? V will be positive, right? Right? That pretty much sums it up. Okay. So you have F fixed, U fixed, the sign of F and U is fixed. Only the V and fixed V over here in the convex case. The concave case, your V can be positive when your object is between F and P. Otherwise, V is always also negative whenever your image is real. that's it about your sign convention for V, F and U. Now there is a sign convention for heights also. I'll just show you. So what does the sign convention for height say? It says whatever is measured above the principal axis is positive and whatever is measured below the principal axis, okay, starting from the axis itself, is negative. That means that if I'm keeping the objects like this, I'll say it is positive. If I keep the object inverted, by the way, if I keep the object like that, I'll say it is negative. Images, in case of concave mirror, you know that they are going to be formed. I'll just change the color from image. So these are the images. Images are going to be formed this way. Okay. So images height would be negative. So whatever is measured, whatever is below the principal axis is negative. If you go behind in the concave mirror, the image is going to come up, right? You don't have an object behind it. So this is positive. Whether your left side of the mirror or your right side of the mirror doesn't matter. Whatever is up is positive. Whatever is up is positive. This is positive. These guys, whatever is erect is positive. Okay, so objects are generally kept erect. So your most of the time your object height is going to be positive because you're going to keep it erect. Okay, the image, if it is real, it is inverted and formed. If it is real, so height of the real image is going to be negative. Okay, when the object was kept upright. Okay, that time the image is going to be, real image is going to be that way. Virtual image is obviously upright, so upright is positive. So you can simply remember that your uprights is positive. Okay, erect or upright is positive, inverted is negative in terms of height. So what about convex mirror? Again, you're going to keep your object this way, so it is positive. Image is always formed in the same direction as the object, so object was kept upright, your image will also be formed upright, so that will also be positive. So when is the height going to be negative? First of all, mostly only for the images, because object we are going to keep it upright. And which images? Whichever are real. The real images will be negative, rest everything positive. So upright is positive, left side, right side doesn't matter. Whatever is down is negative. Had you kept in a fancy way your object like this, your image would have been like this, and both are negative. And this convention is not like a world famous convention, as I said about the one before this. So you may take down as positive, then this down is also positive. Okay, because most of the time what is happening is you have something called magnification, which I'll be discussing a bit later, but I'll just mention it over here. Magnification will be height of the image divided by height of the object. Okay, magnification with respect to height would be height of the image divided by height of the object. Now this ratio is going to be either positive or negative depending on whether the image is flipped or in the same direction as the object. Meaning to say, object was upright, image is upright, and your magnification is positive. Your object, somebody drew the object like this, and you say the object height is negative, image height is also negative. Your magnification is still positive. Why? Because it is in the same sense. So magnification tells you whether they are flipped or not. Okay, so when will magnification be negative? Magnification will be negative when your object is upright but the image is inverted. So when you have an inverted image, upright object, that means whenever real image is going to be formed, that time the magnification is negative, even when your image, your object was inverted, that time a real image will be erect. So again you will have your M as negative. So magnification is negative whenever it is flipped. Magnification is negative whenever the image is flipped. Okay, I hope you got the convention about heights. This is not a big deal because our main concern is the mirror formula. At formula of 1 by f is equal to 1 by v plus 1 by u doesn't have h in it, doesn't, so the convention about the heights doesn't impact this formula. So whatever convention we discussed earlier is going to be useful for the formula. And now if you apply the convention for the homework derivation which I gave you, you are going to get the same formula with the convention if you are applying that derivation. Okay, now we are all set to do questions. So let's get started with the questions.